What's going on, 8th grade? It's Mr. Bradford. Should be Monday the 5th when you're watching this, hopefully, whether it's on USB or actual YouTube. Couple things. The last week, if you haven't done that at this point, don't worry about it. We're just going to call that a wash. We're all figuring this out. The USB kids didn't even get the right YouTube video. Okay, so again, if you're at this point and you didn't do last week's assignment, don't sweat it. Just move on with this one. Another thing, I sent out an email to all you guys. Something that I need to clear up is the Zoom meetings that I'm doing. That's not where I'm going to be teaching anything. It's just where you can come every day if you have a question and we could explain some things face to face. Not mandatory. It's not where I'll be doing any instructing. It's just kind of like a medium where we could speak more effectively. So last week we did some stuff with the sun. I pulled a worksheet off the internet. It was what it was. This week we're going to do phases of the moon. Have a little bit more going for you. So I'm just going to go through this whole thing and then we'll have this worksheet right here by the end of it. So I got the phases of the moon. I'm just gonna read this. Changes in the moon's positioning as it revolves around the Earth results in more or less of the sunlight reflected from the moon being visible when observing the moon from the Earth. This causes the moon to appear to change shape from Earth. Right? We all know about the moon phases by now, but maybe not as much as we need to. The moon rotates on its axis and revolves around the Earth as the Earth revolves around the sun. It takes about 27 Earth days for the moon to rotate on its axis and about 29 and a half Earth days, or a month, for it to revolve around the Earth. Because the moon's period time of rotation on its axis and period of revolution around the Earth are nearly the same side of the moon always faces Earth. What they're basically saying is, while the Earth's orbiting the sun, it's rotating, and while the moon, is orbiting the Earth, it's rotating. Because the rotation is exactly the same, it's showing the same side. And we'll watch a video later on to explain it. A pretty cool video, I'll say so myself. As the Earth and moon orbit the sun together, pattern of day and night on the lunar surface constantly changes. We refer to the percentage of illumination on the visible face of the moon as the moon's phase. Again, so how much of the Earth or how much of the moon is visible from the Earth is referred to as the moon's phase. There are 8 major named phases that have been known throughout human history. So this is the side that we always see, and this is the side that we can only see because of satellites and stuff like that. So we have new moon or no moon, waning crescent. I don't know if it's been over it yet. I don't know if I read it, but waning means it's getting smaller. So let's go this way. New moon, waxing crescent. Waxing means getting bigger. First quarter, see, more than that. Waxing gibbous, because it's still getting bigger. Then we got the full moon. Waning gibbous, because it's getting smaller, waning. Last quarter, and then waning crescent. So we have the phases of the moon right here. New moon, when it's blah, blah, blah. I'll go back up over this at the end. So here it is. Waxing means the moon is growing. If the moon is getting bright from the right, it is waxing. Waning means the moon is shrinking. If the moon is dark on the right, then it is waning. So let's go over these moon phases, I guess. That's not a new moon or a full moon. I think that's an eclipse. Waxing crescent, right? Because it's bright on the right side. First quarter, waxing. Waxing gibbous. Full moon. Waning gibbous. Third quarter? Or last quarter? Last quarter, waning crescent. Alright, so we're going to go through this video right here. There's going to be some questions over this on the assignment I gave you, so pay attention. You might even have it out, or you can go back and finish this video whenever.
See, the moon is always the same. It never changes. It's the same size and shape, round like a ball. But it looks different to us here on Earth because of the way sunlight hits it. That's right, moonlight is really sunlight. And it changes because the moon is going around the Earth and the Earth is going around the sun. Everything's just going around. Okay, let's say that this baseball diamond is the orbit of the moon. Now, the diamond's square and the orbit's round, but you get the idea. Now we need a sun. So let's say that the Earth is on the pitcher's mound. Now see, by the way, the scale of this globe and this moon are about right with respect to the orbit of the moon. That's the baseball diamond. Now notice that right now, when you're standing on the Earth, you can't see the moon at all. This is what we call a new moon. And the reason you can't see it is the moon is between you and the sun. Now the moon orbits the Earth in this direction. So when the moon gets to first base, it's a half moon because sunlight is falling on half of it. Huh? Then it keeps running to second. Now when the moon's back here at second, it's a full moon. That's because the moon is on this side of the Earth. And here's a trick. The moon's orbit isn't flat. It's tilted. So a lot of times, when the moon's back here, will be way up here. But notice it's still a full moon. And this is why most of the time, the Earth's shadow doesn't fall on the moon. It's almost always full. Got to keep moving. On to third. So over here at third, it's a half moon again. But look, the shadow's on the other side. That's because we're on the other side of the Earth. Well, time to break for home. So with the orbit set up like this, the moon would end up right on home plate. The moon scores a home run every month. Well, that's astronomy for you. Or baseball. Well, I guess it's both.
Alright, so there's your video. I noticed the second time around they were calling it half moon, when up here it's first quarter and last quarter. And the only way I could think about it is they're calling it a quarter because if you imagine that's only like a fourth slice of the moon, right? Because the whole back, in theory, is hidden. So if the back is hidden, that's half hidden. And if the front part right there is hidden, that'd be 3/4 hidden. So that must be why they call it a first quarter. Bill Nye is old. They probably had different terminology back then. Who knows? Alright, so here's the video that I was talking about as far as how the moon has the exact same rotation as the Earth. I don't think I even knew this really, so I found this pretty interesting.
In 1959, the Soviet spacecraft Luna 3 beamed back images of something Earthlings had never before seen, the far side of the moon. We always see the same old side of the moon because the moon rotates exactly once on its axis each time it orbits Earth. If it weren't spinning at all, we'd get at least one 360-degree view of its surface with each lap. If it were spinning twice as fast, we'd also see the moon's entire surface more than once per orbit. But instead, our moon's motions, like the spin and orbit of most other moons in our solar system, are remarkably in perfect sync. This wasn't always the case. Our best guess is that our own moon formed due to a massive asteroid impact, and its initial spin and dizzying 10-hour orbit were almost certainly not in sync with each other, though we don't know which was faster. At such close range, Earth's gravity deformed the moon into a slight oval, with one of its bulges facing Earth. Those bulges quickly swung out of alignment thanks to the moon's asynchronous spin and orbit, but Earth's gravity continually squeezed them back again. What's more, this gravitational tugging would have influenced the moon's rotation rate. If it was spinning more than once per orbit, Earth would pull at a slight angle against the moon's direction of rotation, slowing its spin. If the moon was spinning less than once per orbit, Earth would have pulled the other way, speeding its rotation. Whatever the case, it took just 1,000 years for the Earth's pull to adjust the moon's spin enough that one rotation of the moon corresponded to one trip around the Earth, leaving one side forever locked facing away. We do end up seeing some of that far side because the moon's elliptical orbit gives us peaks beyond its average eastern and western horizons, and its tilted axis causes moon seasons, revealing more of the lunar north or south poles. But those glimpses only add up to an extra 9%, leaving 41% of the moon hidden from Earth. Satellites, starting with Luna 3, have allowed us to map the rest, but it's safe to say that our relationship with the moon is still pretty one-sided. I'd like
So there
to
you
say
go. Pretty cool. I never saw it laid out quite that way before. What am I doing on time over here? Okay, just about right. So there's a whole, obviously I'm going through a whole ton of videos. I'm skipping some. There's a lot of resources here for you guys. I'm going to leave the link to this website at the end of your homework or whatever. Because there's this cool game. I played it a couple times. But you got to go through here and match the things to what they are. And of course, you know, it saves everyone's stuff. Like I said, oops, I meant to click that one, I swear. I'm number 17, oh no, I'm not, 174 out of everyone who's played this game. So maybe you guys could have fun trying to get in the top, I don't know, 100. That'd be pretty cool. Anyway, so that's about all I have for you. As far as the homework, let's see. This is what it's going to look like. You know, you guys did a decent job of getting it turned in. Like I said, turn it in any way you can. If that means downloading this doc and editing it and uploading it to Google Classroom, do that. If that means for you packet kids, writing it on a piece of paper and turning it back in, sending me a picture on the email. Although I do ask, if you send a picture on the email, still go in and turn it in on Google Classroom, but just say like email so I know. That way it's easy to go through and like keep track of who all turned it in and stuff. If I'm forgetting anything, I'll send out an email. You guys can always email me with questions, and then we got the Zoom meeting all week. So until next time.